There are three approaches to problem solving: experimentation, simulation, and mathematical model, which are classified as analytical or numerical. It is possible to obtain an exact solution for analytical problem, whereas a numerical problem will yield an approximate solution. In science and engineering, we set up experiment together information and data, test hypothesis, and compare theory and practice all sorts. The results are expensive experiments typically require a large amount of expensive equipment and facilities. As a result, scientists and engineers are also using simulation to solve a problem. Simulation are defined as a model of representation of a series event in science, engineering, and business. Presently, through computer calculation to study effects of potential and on decision. Problem statement: a constant temperature, pressure, volume. The thermodynamics process work can be calculated is W, integration of B and AP dv, differentiation of velocity. Where W denotes P works, pressure, and denotes volume. Given the data of the table below, compute the work W is a combination of trapezoidal rules, Simpsons over 3 rules, and Simpson 3 over 8 rules. All three rules must be included in computation. Pressure P Pascal 300 is a volume 0.5 meter cubes, 287 1.5 meter cube, 276 2.5 meter cube, 258 4 meter cube, 251 7 meter cube, 239 is 8 meter cube, 190 is 10 meter cube. Fact: thermodynamics process chosen as a project topic. The idea: explore various applications of thermodynamic process. Learning issue is understanding numerical integration methods. Extend ratio different numerical integration techniques in thermodynamics. Fact: focus on numerical integration chapter. Implement practical example relate to integration. Learning issue is difficulty in direct integration. Action: create example for numerical integration method mentioned. Thirdly, importance of accurate data approximation. Idea: experiment with practical calculation using this method. Learning issue: understanding integration approximation method. Action: compare and contrast different numerical method and mention. Method: trapezoidal, Simpson 1 over 3 and 3 over 8 quadratic equation. Brainstorm real world application for each method. Application numerical method in thermodynamics. Implement calculation using each method in thermodynamic scenario. Objective: to calculate the word associated with constant temperature, pressure, volume, and thermodynamic process. To utilize the combination of numerical integration method, including trapezoidal rule, Simpson 1 over 3 rules, and Simpson 3 over 8 rules. To employ this numerical method, technique qualitatively to approximate the work done during the process. This is the data from a thermodynamic process. So the Pascal is 300 and also the volume is 0.5 meter cube, 287 1.5 meter cube, 276 2.5 meter cube, 258 4 meter cubes, 251 7 meter cube, 239 8 meter cube, and 119 is 10 meter cube. This is trapezoidal method. Formula of trapezoidal method. You can see F. So the integration by you can see the volume. No, the Pascal of the project. We conclude all the data and integrate and 9.5 over 2 result of the integrates times with 2004 and you got 9,590. So this is a calculation for 1 over 3 Simpson method. Formula 1 over 3 Simpson method is that odd and even. So for this 1 over 3 Simpson method is a different method from a trapezoidal. So you can see 10 minus with 0.5 out over 6 and you got a 1.5833. So this is stable or carry over. So 1.5833 divided by 3 is a sum of 490 plus 4 times with 784 and plus 2 times with 500, minus 27. This is in the formula. So you get 2469.95 kilo J. So this is a formula for 3/8 Simpson method. B differentiate. So B minus with A times with N. So N is how many datas in a Simpson table, 3.8 Simpson table. So you got a 10 minus with 0.5, you divide by 6, and you get 1.5833. So this is a table for the Simpson 3.8 Simpson rule. So we start with 0 and end with 6 for I, and xi is x times with the value of, I think, value of the uh, meter cube. So 0.5 is the start, and we got a 490 and 1553 and 258. So you got a 24,000 and 2,472.92 kJ. So this is the result of each method. For trapezoidal is 9,590 kJ. 1/3 Simpson method is 2469.95 kJ, and 1/3/8 is 2472.92 kJ.
Assalamualaikum. For the literature review part is a critical and comprehensive summary and analysis of the existing body of published work on a particular topic or research question. It is a key component of academic and research paper, thesis and dissertation. The primary purpose of a literature review is to provide an overview of the current state of knowledge. Moreover, this chapter subtopics include the fundamental thermodynamics process, Fila table, and explanation of the method used. Firstly, for the fundamental thermodynamic process, a process is a route along which some attribute deviate from their initial values and the state of the system change. There are 6 different categories of process related to the thermodynamics, as can be seen in table 2.1. First is adiabatic, which is adiabatic process. The system undergoes change in pressure, volume, and temperature without any heat entering or leaving the system. The main element is no heat transfer, temperature change, and work done. Second is isothermal, which is thermodynamic process or system in which the temperature remains constant throughout the process. The main element is constant temperature, heat exchange, expansion or compression, and reversible expansion or compression. The third is isobaric, which is system in which the pressure remains constant throughout the process, and the main element is constant pressure, volume change, and heat exchange. The fourth is isochoric, which is the volume remains constant during the process, and the main element is constant volume, no work done, and heat change. Next is isentropic. Isentropic is the thermodynamic process or system that is both adiabatic and reversible, and the main element is reversible, idealization, and constant entropy. And last, the isentropic, that is both adiabatic and reversible. The main element is constant entropy and reversible. For the methods used for solving, one of the method is trapezoidal rule. The trapezoidal rule, commonly referred to as trapezoid rule of trapezium rule, is a numerical analysis method for approximating the definite integral. The trapezoidal rule is an integration rule that divides a curve into smaller trapezoid in order to estimate the area under the curve. The summation of all the areas of the small trapezoid will give the area under the curve. When the underlying function of smooth, the trapezoidal rule does not provide an exact number as Simpson rule does. This is caused by the fact that Simpson rule employs quadratic approximation rather than linear approximation. Both Simpson rule and the trapezoidal rule produce an approximate number for the integrals, but Simpson rule produces an even more accurate approximation value. The trapezoidal rule formula is given below. The second is Simpson 1/3 rule. This rule requires 2 minimum segments where the trapezoidal rule only one. We generate an area A1 with n equals to 2 segments under Simpson 1/3 rule using Newton forward difference up to second order. provide by a fundamental formula of this formula. And for better accuracy, the intervals A and B is divided into n equal to 2m, m and are integer. Subinterval x s1 of equal with h ban, such as the integral is approximate by composite Simpson 1/3 rule as this formula. Lastly, for the last method is Simpson 3/8 rule. This rule, also called Simpson's second rule, is another method for numerical integration proposed by Thomas Simpson. It is based upon a cubic interpolation rather than a quadratic interpolation. Simpson 3/8 rule is as follows with this formula, and the integral is more accurate approximate by the composite Simpson 3/8 rule by using this formula. Lastly, for the filler table, our group list down the fact, idea, learning issue, and action for the better of any calculation and result.
Next is for the methodology. Research methodology simply refers to the practical of how of a research study. It focuses more on the methodical ways in which a researcher plans a study to guarantee accurate and trustworthy outcomes that answer the goals, objectives, and research questions. The workflow of this project is depicted in the flowchart below. First, we conduct discussion among group members to find and pick a suitable topic for our group project. Then, we study and state the problem statement and objectives for the project, perform a background study and literature review on the selected subject or topic. Then, after that, we apply the methods chosen to solve the problem statement that's created and present all the results and calculations that involve that. Then we discuss the result that we obtain, and lastly, we do the conclusions.
Assalamu alaikum, Doctor. My name is MUKHTAR. Here I will present a discussion part. In evaluating methods for calculating work in a constant temperature, pressure, volume, thermodynamic process, the trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule were employed, or we used that three methods to solve this problem. The results indicate that the trapezoidal rule is simple and fast, but less accurate for complex curves. And the result we got by using the trapezoidal rule is 2463.615 kilojoule. Also, the other method was a Simpson's 1/3 rule, which also provide balanced accuracy and efficiency, and the result we got was 2469.95 kilojoule. While the third method we used was a Simpson's 3/8 rule, and this method is the highest accuracy. We got the result of 2472.95 kilojoule. The choice of these three methods depends on the function characteristics, with calculated work values guiding methods selection for future similar calculations. That's the discussion part. Thank you so much, Doctor, for your listening.
Right. Based on the calculation and observation that have been done on the study, it can be concluded that between both 1/3 and 3/8, Simpson's rule method is the best and most accurate method to solve this problem. Through this study, it is clear that there are some circumstances in the nowadays field of civil engineering that call for the employment of a numerical technique to identify pattern characteristic. This now numerous well-known function that could not be solved using analytical method might instead be solved precisely thanks to the numerical method. The numerical method provides a different approach that will streamline the calculation process and help the engineer to resolve any problem involving civil engineering in less time while keeping the accuracy. These methods are applicable in real-life situations. In order to generate young generation with problem-solving skills, these numerical methods are demanded to be utilized in their daily lives.